All right, so where do we leave off here? We were talking about the evolution of our languages, C to C++ to Java, how we kind of got rid of structs in Java, but because you could pull everything off with classes. Swift, more modern language, actually brings structs back, so that you did have that decision whether you wanted to represent something as a collection of variable value pairs or wanted to have methods. And structs are always sent as value as opposed to by address. So, they kind of backtrack away from what Java was doing. Kind of an interesting thing here, though, if we go back up to this point, we see we have C, we got to our C++, we saw our Java, we talked about how we got to C#. Java, C# are pretty similar to each other in terms of the features they support. On the Objective-C side, we have Objective-C and Objective-C 2.0. So for years and years and years, Apple didn't really update the Objective-C language. In fact, I would probably say that Objective-C is fairly archaic as far as programming languages go. I showed it to you today, and it's readable enough, but certainly it doesn't feel as evolved as like Java does. There's things still in it, a lot of details still left in the language. So you kind of look at Apple and you're like, why? Why did you leave all this stuff in the why didn't you upgrade your language? You're coming out with all these cool pieces of equipment and stuff like that. Why didn't you do the same thing with your languages? Well, you got to keep in mind, back in this time period here, this was Apple versus Microsoft, right? So let's say for every 1,000 programmers that were writing stuff for Windows, you had one programmer that was writing stuff for Mac. Okay, something like that. So basically, the people who were Mac fanboys back then, they didn't care what the language looked like. Apple was better no matter what. Okay, nobody was complaining about Objective-C. They had a cool IDE for Objective-C called Code Warrior. It was terrible, but it had a really cool name. So, the C programming guys liked it, or the Objective-C programming guys liked it. So the idea here is that Apple didn't have to convince these guys to stay. They were staying because they were drinking the Kool-Aid. All right? They updated Objective-C to 2.0 here, but this really wasn't a change in the language. It was just adding this was a very much a general purpose programming language. This had a bunch of Apple stuff embedded into it. For working with the Mac operating system and iPhone, things like that. So when iPhone comes out, so iPhone would be somewhere down, maybe in this, this is a this is the time axis. iPhone comes out somewhere around here. So the number of Objective-C programmers that exist goes up greatly. Because before, the only people who were writing Objective-C were people who were writing Apple or writing Macintosh desktop applications. Right? Which was a very small percentage. Relatively speaking, most people wrote stuff for PC. And the people who wanted to work for PC and Apple for business applications, they would use Java. So there wasn't a whole lot of reason for people to write stuff in Objective-C unless they were only writing for the Mac. All right? So why did these guys, why didn't Apple keep updating? They didn't need to impress these guys. Well, now all of a sudden we have a zillion more people writing for iPhone. So you think, okay, well, iPhone, the App Store has been out for 7 years now. 7 years, why haven't they updated the language in those 7 years? Well, they had a captive audience. People came over from here to write an Objective-C, not because they liked Objective-C, but because they wanted to make money writing stuff for the iPhone, right? It was a cash cow. You're a freelance developer, you want to make some money? The place to make the most money is on the Apple App Store. You make more there than you do on the Android App Store. That's the way the economics of it works. Okay? Part of that might be that the people who have iPhones tend to be more affluent, or the people who are buying apps tend to be more affluent. Maybe the more of the reality is that the kids who have iPhones have parents who are more affluent and they don't have the parental controls turned on. You know, that's why you have these apps like Game of War and stuff like that are making zillions of dollars because, you know, until the parent gets their bill and sees the kid spent $600 on in-game coins this last month. But in any case, Apple didn't make any effort to come out with a new language. And they just kept getting more and more and more developers. Finally, about a year ago, Apple announces the Swift programming language. Brand new language. Okay? You know, because Apple's such an innovative company, they really wanted to make life easier for these guys, right? No. No. That's not why they came out with Swift. These guys were not complaining. These guys were not complaining. You had two other groups in the world here that we're not... oh, one of them we have here. Let's show the other one. So the other group with PHP, right? Let's put that down here. Any of you done anything with PHP? Okay. Do you know what came before PHP? PHP is a web language, right? Yeah. So it's a programming language based off of C with a kind of focus on writing stuff for server-side web pages. ASP? Yeah, no, ASP the first one. Yeah. ASP was probably somewhere in, well, actually, ASP was probably about there. PHP came out first, I'm pretty sure.
Excuse me.
Go ahead.
I have a question.
Yeah.
What program is the easiest language to learn and the one that is the easiest language to learn and that still makes sense in the
Oh man, what a terrible question. No. See, it's a terrible question because remember day one of class I said that all languages are the same, right? It doesn't matter what the language is. So, you know, I don't think there's a real answer to that question. You know, if it really depends on the type of thing you're doing. So, for instance, if you're going to be a web programmer, if you're going to be writing stuff for web pages, you're probably not going to go and learn C++ because that language doesn't lend itself to the tools that exist for delivering web content. PHP might be a good place to go. On the flip side of it, C# might actually also be a good place to go for that because now you have one common language where you can write desktop applications as well as drive ASP.NET, web-based applications. Okay, so but then you're stuck in using IIS, Internet Information Server. So, you know, at the end of the day, I don't think it's impossible to say this language is the best. Each language has its own character, but every one of these languages, no matter what it's doing, is going to have facilities for memory, asking questions, and repetition. And then they're going to have an existing framework that kind of lends itself to certain kinds of problems. So, for example, PHP here is a framework is basically based off of C. It's a C programming language, so it looks a lot like C, but it is loosely typed, and it's interpreted. But it has a whole bunch of functions built into it for doing web type stuff, talking to MySQL databases, splitting strings up, things that you have to do commonly in parsing web forms, that kind of stuff. So now I asked the question though, PHP was probably our first popular web language. What came before PHP? The early days of the internet, when we just first started having web pages. We first started, HTML displays stuff. We needed something to process web forms. So when you go onto a page and you type in your username and your password and hit submit, what processed that authentication prior to PHP?
Server-side or client-side?
Huh? CGI, okay, not a language, but it's a technology. So we're going in the right direction there.
Oh, you want server-side?
Always server-side. Server-side, client-side is not going to process forms. Well, it's sort of fake now. Client-side does process forms today, but back then it didn't. Typically, we'd think of client-side as validating forms, and then the server-side processing it. So she mentioned something called CGI, which is Common Gateway Interface. So this was a technology for processing web forms. So somebody put their username and password in. Typically, the popular language for this was something called Perl.
Oh,
Okay, and Perl was actually a programming language that Unix system administrators were used to using for doing Unix system administrating crap. Okay, so and what they did is they then took that language that was designed for generalistic type problems and they applied it along with the CGI technology for processing web forms. All right, so we would call this some of the early days of the internet, when we were just starting to see dynamic web pages that had to process web forms and things like that. So out of that grew a necessity for PHP. PHP is still pretty popular today, but it's actually starting to be supplanted, right? What do we have today? What's kind of been replacing PHP? Okay, so we have Ruby. Well, hold on, it's not just Ruby though, it's Ruby on Rails. And what does that mean? What does Ruby on Rails mean, or is it just fun to say? This gets back to our little buzzword stuff, right?
Yeah.
You never hear somebody just say Ruby. It's always, oh, I use Ruby on Rails.
Ruby is a language.
Yeah.
Rails is a framework.
That's true. What kind of framework? Okay. PHP typically runs on a web server. Most PHP applications are going to run on Apache. Okay, so Apache is going to be the common enterprise level web server for processing PHP. Anybody who's doing ASP.NET stuff is going to be on IIS. Rarely will you see somebody running PHP on Internet Information Server, which is Microsoft's web server. Nothing wrong with it. There's nothing wrong with Microsoft's web server. In the early days, people would have said it was crap, but there's plenty of enterprise places out there who have their web servers running through Internet Information Server, which is Microsoft's thing. But the bottom line is, if you're a Microsoft shop, chances are your web applications are going to be ASP.NET web applications written using Visual Studio, Microsoft crap. If you're a Microsoft shop, all your stuff is Microsoft crap. Makes sense, right? You know, just like, you know, if you're an Apple person, you have the, you know, the laptop and the desktop and the watch and the phone and all, you know, all this stuff. All of it just talks to each other, right? I have Apple TVs at my house, the little boxes, because I can use my phone as the remote.
Where does JSP come into this picture?
JSP? Okay. Oh my gosh, I don't like you people. No, JSP is not JavaScript. Okay. All right. I'll expand this a little bit. No, server side. Just relax. Just relax. It's actually pretty related to what I'm about to talk about anyways. All right. Old crap. A little bit newer crap. I got to get this Objective-C and Swift back over here. So this, I've kind of created an area over here for web. This is web languages. And you might say web languages are also interpreted / loosely typed. I think that's going to be true of pretty much everything we have in here except JSP. Okay, so we have PHP and Apache that comes out. PHP is a brand new language, right? It's a language that's based on C, so people who've had C programming kind of recognize it. A lot of the people who did PHP jumped from Perl. And Perl is also based on C, so it wasn't that big of a jump. But then you said, you had these guys, hey, I'm a Java programmer, I want to play too. All right, so the Java guys said, okay, and this is kind of the problem with Java. Java created a whole bunch of disjointed frameworks. So they came out with something called JSP. And JSP it's Java Server Pages. All right, this was JSP and PHP are solving the same problem. PHP solves the problem by embedding PHP language inside of an HTML page. JSP solves the problem by embedding Java language inside of an HTML page. Apache then processes that. Okay, that makes sense? The same thing is true of ASP. Okay, ASP as well as the more modern ASP.NET. The difference with these guys, though, is that Apache never had an official, well, never really had a fully functional version of an ASP interpreter because this was something that they had on IIS. We'll change the color of this. We're going to say web servers are green. So those are web servers. The blues are the languages. So these two guys actually were really only on IIS. There was some like beta modules and stuff that sort of kind of let you do ASP on Apache. Nobody would do it. Nobody did it. Okay. JSP was Java server pages, and it didn't even work very well with Apache. You had plugins for it, so it actually used something called Tomcat. Isn't it bad that I remember so much of this stuff? All right, so JSP ran in Tomcat. You also had another technology here called servlets. Servlets. Okay. JSP was a direct competitor with PHP. Servlets were like CGI. So servlets was actually a back-end Java program, a full Java program that got called from your web form, as opposed to embedding a programming language within your HTML page. PHP and JSP embed in a page. Okay, so we're going to call this the early days of the internet. Then PHP comes out. Kind of our popular web server back then was Apache. IIS then came once Microsoft wanted to get on board. Once Java said, hey, we have a bunch of programmers we want to play to, they came out with a really crappy web server that nobody uses anymore called Tomcat. This guy was known as what's called a servlet container, complete garbage. This is actually one of the reasons why Java kind of failed, I think, in the web space, because so many of their technologies were disjoint. And it's one of the reasons why Microsoft has actually been fairly successful. So, getting back to his bad question, he asked what language was a good language. So I'll play devil's advocate. I don't agree with this, but I'll say if you could only learn one language today, one language, and you wanted it to give you the most flexibility to solve the most kinds of problems, I think C# makes sense. All right. The reason for that, first of all, right off the bat, you are pigeonholing yourself into the Microsoft world, right? From a desktop perspective, not a huge deal. There's plenty of Windows installs, right? From a web world problem, I think you're still also okay. IIS has only gained popularity over the years. It's caught up to Apache. There's probably more Apache web servers out there than there are IIS servers, but you're in decent company writing stuff for IIS for web. All right? So C# lets you write native Windows applications. It lets you write dynamic modern web applications through IIS, all using the same language, because you're actually writing your stuff in what's called ASP.NET, which is this guy right here. And the difference between ASP and ASP.NET is ASP used a older language called VBScript. Okay? ASP.NET says nobody uses VBScript anymore, so why don't we let our guys use our modern languages? You can actually write ASP code in C#, Visual C++, Visual Basic. You could do it in J# until they took that away. Anything else in there? You can do it in Visual Fox Pro, but whatever. C#. This is Microsoft's flagship language. All right. If you are still writing stuff in Visual Basic, people should punch you. All right. All right. So, if there is a language that you shouldn't learn, Microsoft's documentation would probably say that Visual Basic is easy to learn. Visual Basic is a garbage language. Doesn't. You can quote me, and it's on recording. All right. Okay. C#'s good language. This is a good language, and it's universal, and you can write desktop stuff with this. You can write web stuff with this. With Mono, the Mono library, you can actually write Mac stuff with this. Yeah, it's not quite as full-featured as writing it natively for Windows, but you can pull it off. The only thing you can't do is you can't write iPhone and Android apps with it, but there's actually one of the cross-platform products. I don't know if it's Appcelerator or one of the other one. One of the products allows you to write mobile applications that deploy to multiple platforms, either Android, iPhone, or Windows, and BlackBerry, I think all of them. And the scripting language you write in is C#. So you could technically pull it off. Otherwise, you can write native Windows 8 applications that nobody wants. How many of you have a Windows phone in here? iPhone and Android, plenty?
Android.
Yeah, we'll get hands for that one, right? Okay.
Do they still use JavaScript then?
Sure.
So where does JavaScript?
JavaScript's a client-side technology. So, oh man, she asked a bad question
And,
again.
and why do they have the JSON query?
All right, hold on. Let me,
Sorry.
No, that's a good question. I'm just having to, okay. So you have your web browser, right? This is your web browser. Your web browser talks to a web server. Whoa, hello. All right. So web server serves HTML pages, web browser displays HTML pages, okay? Web browsers understand two things. These guys understand HTML and they understand JavaScript. Browser does not understand Flash. The Flash plugin understands Flash. So you can get the Flash plugin for your browser, so your browser will pass that off to the Flash plugin. Natively, your browser speaks HTML and JavaScript. That's what it speaks. CSS is a server-side technology. It reads from a directory structure on the server side. So it's embedded inside of HTML, and it says what to download from the server. So CSS is actually an HTML library. So you're going to keep trying to get me to add more to this. This is what they understand. Web browsers speak HTML and JavaScript. Trust me. All right, so web servers have a bunch of modules. So by default, they serve HTML pages. Okay, they can also serve PHP pages if they have the PHP module on there. What does it mean to serve a PHP page? It means it has to pre-process it. It has to run the PHP document before and it serves the output of that program to the web browser. Okay, so whenever a browser requests blah.html, the server just sends it to them. There's no pre-processing needed because the web browser knows how to interpret HTML. It knows how to deal with that. But if it asks for blah.php for the web server is going to look up that file. It's going to say, oh, this is a PHP file. I need to run that program. And what the web browser wants is the output of that program. So PHP documents output HTML and JavaScript. That's what the output of a PHP program is. PHP and JavaScript, or HTML and JavaScript, which happens to be the exact crap that a web browser understands. Make sense? What else can a web server do? Web server can do, well, actually, I want to leave it at that for right now because it'll help me do some other stuff that I'm getting to here, which makes it so that her question wasn't as bad as it could have been. Okay, so you said, where does JavaScript come in? JavaScript is a client-side programming language. So typically, JavaScript is used for validating web forms, because the idea is you type in your username, your password, stuff like that here on your laptop or your desktop computer, whatever. The JavaScript can check to make sure you filled out the form in its entirety within the web browser before you send it back to the server, only for the server to reject you.
So all validations are done before you send it to them?
All validations should be done before you send it.
So that's
Historically, the way it would work is you would put in a username and forget to put in the password. You'd hit send. It would send that web form back to the server all the way over here. It would look and say, oh, you didn't enter in a password. Then it would spit out an error all the way back. So you'd have to talk to the server give a response, talk to the server give a response. So JavaScript lets you handle things like that on the client side. More modernly, more and more stuff is happening on the client side. So I'll actually show you kind of the evolution of this stuff here in a second. But this is where JavaScript lives traditionally, is on the client side. But now when we come back over here, so we have all these technologies. JSP, nobody uses that anymore. Okay? Only people who are interested in JSP are people who are Java programmers who don't want to learn something new. Okay? And they're just so stuck in their ways, like, okay, well, I know Java and I want to do web stuff, so I'm going to use JSP and nobody likes me. All right? There's nothing wrong with it. It works fine, but it's not often. You're not going to go and find very many JSP jobs. Okay? But one thing I want to demystify here, since we're already down the rabbit hole, is all of this crap is the same. Okay? PHP, JSP, ASP, and ASP.NET are the exact same technologies. The only difference is the language. PHP is done in PHP, JSP is done in Java, ASP, the original, was done in VBScript, the more modern is done in the .NET languages. So you pick your language and then apply it to the equivalent technology. All right? Same thing's true down here. Notice that all these guys up here are paired to a web server. PHP requires, we're going to say Apache. It'll actually run an IIS as well, but for my example, let's just say Apache. So PHP needs Apache, JSP needs Tomcat, ASP and ASP.NET need IIS. So all these guys require an enterprise level web server to come with it. Okay? Which means if you're going to code in these languages, you need to have this whole environment set up in order to even test your programs. That makes sense? So now we come to our more modern stuff. Ruby on Rails. Python. Oh, the Node.js. That's a new kid in the block. Oh, Node.js. Cool kid. Buzzword. Sounds like it should be really difficult, right?
Yes.
Okay, right? Just like this. Oh, here. We're gonna go back. Scare the crap out of here. So JavaScript, as if JavaScript, that's okay, whatever. It's a script, makes it sound a little fuzzy, right? So now we're gonna say Ajax. Boom. Okay, we throw Ajax on there. All of a sudden, okay, now something's hard. Something's more difficult, right? Okay, what's Ajax? Ajax is a JavaScript library. That's all it is. It's a special library for JavaScript. And what did it do? It allowed us to do more stuff on the client side. It took more and more stuff away from the server. At the end of the day, the job of Ajax was for our web pages to not have to reload. So more error checking happens in real time on our web page without the page having to reload, because the JavaScript, the Ajax library using JavaScript, is running all the time. Okay? And then when Ajax wasn't cool enough anymore, that's when they released some of these other technologies. Okay? Huh?
jQuery.
Okay, fine. So from Ajax we went to jQuery, right? Oh my gosh, jQuery. This just sounds hard, right? You have J in there, you have query in there. Querying is hard enough. Now you have jQuery. It's a whole new kind of querying. Okay? jQuerying is a really fancy way of saying this. Hey, I know how to rewrite the document object. Smiley face. That's all jQuery does. Okay? In JavaScript, you have this thing called document. And document gives you access to the thing that's on the page. Okay? Whatever's on the web page. That's how JavaScript, a script inside of an HTML document, that's how it refers to the current displayed web page. You could almost think of document as being like the this in the JavaScript world. It's not exactly an equal thing, but let's just, so we can kind of attach it to what we were talking about at least a little bit. Okay? jQuery is just a set of JavaScript libraries for rewriting that document object in real time. So that when you are doing stuff in your page is changing without reloading. Okay? jQuery is an evolution of Ajax. But what happened is people started getting comfortable with Ajax. It wasn't scary anymore. So we had to come out with a new name, jQuery. Make sense? All this technology crap is the same stuff. It's the same stuff. See, I scared him off. He left because I said his question was stupid. So we have Ruby on Rails. Oh man, it wasn't enough just to call the language Ruby. Now we got to say, oh, it's on Rails. What the heck does that mean? I'll show you what it means. Ruby comes with its own little web server called Rails. Guess what? Now you can write your little web application without having to spend a whole bunch of time setting up an environment. It's all self-contained. You called it a web framework, right? Rails is a web framework, which is a fancy way of saying my own web server. So you design it, you get it all working, and guess what? Once it's working, if Rails isn't, your little, simpleton web server that's running on your local machine for you to do all your testing, if that can't quite handle the zillions of people you're going to expect to hit your website, no problem. You go and get the Rails plugin for Apache, and now you could just modularly move this entire thing up to Apache. It just works. You don't have to change anything. This is object-oriented web programming.
Is that an open source?
Oh, sure. Yeah. Okay, so this is object-oriented web programming, right? We could pass the language and the thing that runs the language around as an object. So we just call this guy Ruby on Rails. Boom. Make sense? Okay, well, wait a minute. What if I'm not a Ruby programmer? I only know Python. Okay. Nobody says on Flask. Okay? But the reality is we have this, which was the same thing I showed you right here. Don't like Ruby on Rails? It's not because you don't like Rails. It's because you know how to program in Python, not Ruby. So you want to do the same crap? No problem. Here, you have Python and you have Flask. You have an object-oriented environment for writing web pages, dynamic web pages. Make sense? So if we're keeping these the same, we'll say Python on Flask. Okay, but wait a minute. I'm not a Ruby programmer or a Python programmer. And I heard about this really scary, Node. That just, it's almost like, I don't know. It seems so abstract, just Node. It's like beyond scary. It's not even self-descriptive. It doesn't even sound like a language. Okay? Node.js, it gives a little bit away here. Yeah, I'm gonna rewrite this a little bit. I'm gonna steal this. Oh, actually, I didn't mean to do that. JavaScript on Node. That's what Node.js is. It's JavaScript on Node. Now this one actually probably makes the most sense out of all of them. Okay? Because remember, as she pointed out, or asked, what about JavaScript? Well, all web browsers know JavaScript. Okay? So when you're doing the client-side crap over here, so client-side is HTML and JavaScript, right? Well, server-side was you would host HTML and then maybe you'd have PHP over here, right? Okay. Well, now, if you were already writing your client side in HTML and JavaScript, so you were already, let's say, a JavaScript pro, why not write your server side in JavaScript as well? Same language on both sides. You can do all your front-end stuff, all your client stuff in JavaScript, and you can do all your server-side stuff in JavaScript. So instead of PHP with Node.js, you write your server-side stuff in JavaScript. A language that's already been out for a long time, that a whole lot of people already know who've been doing web stuff, okay? And maybe they relied on another, a PHP programmer to do the hard, back-end stuff. We just say back-end stuff, and it makes it sound more difficult, right? Okay. Well, I'm a front-end guy. Okay, I do UX. So that's what? Have you seen that UX when you look for jobs? What does UX stand for? I'm really more into UX than back-end. It's user experience. What the page looks like. Okay, and they call it UX because it makes them sound, like they have an Apple Watch.
I think I've seen that in one of the job description, and I thought it was a tool or something.
See, it's so dumb that we just come up with all these fancy things to make us sound smart. And you just got to get through all the crap and realize they're all the same thing. Every one of it. You come back in here. Look, I learned Ruby. Cool. You want to do web stuff? Sure. Yeah. Why don't you work with Ruby on Rails? It'll do it all for you. It's they work very well together. Okay. Ruby on Rails has a library associated with it called Gem. And Gem has a whole bunch of crap you can download to make your web stuff on Rails that much easier. It's kind of like PHP on steroids. When PHP first came out, it was a language designed for web stuff. Well, the web of today is a little bit different than the web when PHP first came out, right? It's evolved a lot. So these newer languages, they're not superior to PHP. PHP is fine. There's nothing wrong with PHP. It's a perfectly acceptable language for web stuff. In fact, these languages themselves, Ruby and Python, are not really dissimilar from PHP. In fact, I wouldn't say one language is superior in any way to the other ones. The reality is it's in terms of the libraries that are available to them. As a PHP developer, you're stuck with the libraries that PHP knows about, which allows you to solve a lot of web problems. But Ruby on Rails abstracts a lot of problems because it kind of comes with this one object that has everything in it. So it's a self-contained monster. You don't have to worry about your PHP scripts breaking when the Unix system administrator updates Apache. That can happen. If they put a new version of PHP on Apache on their server, all of a sudden your scripts might break because it might take advantage of something they took out of the language. With Ruby on Rails, everything updates together. When Rails updates, your gem libraries will update as well. Okay, so it's the object-oriented version of PHP with Apache. If you're a Python programmer, no problem. Here, you like Python, there's your language. You want to run in web stuff? Yeah, use Flask. Why did Flask come out? Well, because we had Python people who were losing to Ruby. Well, why did they lose in Ruby? They wanted to do web stuff. Okay, we'll invent Flask so you can do web stuff with Python. Same tool. Node.js. Well, besides sounding cool, this guy's old school. He's new school, which is old school. Okay, this is the new kid on the block, and what has he done? He's gone back to something that's been around since the beginning. Okay, in the early days of client-side programming, you had VBScript and JavaScript duking it out. And JavaScript won. So all your client-side guys are all writing JavaScript crap. And now, hey, I can use that same language I've been using for the last 20 years on the server side. And I can pretend like I'm all up on top of stuff because I'm using the brand new tool, which lets me use my old tools. Make sense? Okay. All this crap is the same. It's all the same. To demystify one other thing, something when you're looking at jobs, something you might see out there is full stack. Have you ever seen this when you're looking at various jobs in the technology industry? They're looking for somebody with full stack experience. None of you have seen it? What does full stack mean? We want you to know everything that we know. That means you understand the full stack, right? Generally speaking, full stack would be kind of what I've just shown you here. Understanding the web side of things and the mobile side of things, and you understand the technology from the bottom to the top. That's the full stack. That makes sense? Okay? But realistically, full stack's going to mean different things to different people. You might go and talk to some guy who says, well, I've been doing full stack stuff for a while. He's got his Apple Watch on. Okay? And, maybe he just knows this amount of stuff. But you know this amount of stuff. Compared to you guys knows everything. Right? Okay, so, nobody knows everything. Right? I think I told you guys maybe the second or third class that I've been literally programming in Java since the language came out. I know maybe 20 or 30% of the language. I can use anything in the language, but I've only had the occasion to use 20 or 30% of what's in there. I might even be overestimating. It might be more like 10 or 15%. I understand how the whole language works from a structure perspective, but I haven't used, look back at this documentation. Where are we at with the Java documentation? So here we'll go back to all classes. Nobody's used all of this crap. Here's all the classes in the language. It's tiring just scrolling through it. Okay, nobody's used that. Here, let's just find something really strange. The accessible context class. What's that? Let's go look at that guy. Accessible context represents the minimum information all accessible objects return. Oh, well, heck, this guy's abstract. You can't even create instances of this dude. Dumb. All right, let's see what else. You see what I'm getting at? Oh, the ACL class. Almost used it once. Interface representing an access control list. It's a data structure for network stuff. Yeah, there would actually be for security stuff. It'd actually be something you might stumble upon if you were doing some security stuff. But hey, I've never actually used it in Java. It's there, but every one of us in here knows how to use it. Here, we'll go down to some methods. Here, we'll look at a simple one first. Class method or instance method? Instance method, how do you know? No static. How do you call an instance method? Instance of the class in which the method was defined. What class was this guy defined in? Something called ACL. It's actually an interface, not a class, but don't worry about it. Not important for us. Right? So we know how to use it. We just had to go find it. Make sense? Okay. Nobody knows everything. If they say they do, they probably know less than you think they know. Okay, yeah, so full stack, all they're saying is make sure you know everything that we do. And so when we interview you, you can talk about all the technologies we use, and we'll assume you know everything then, because that's full stack in terms of them.
What do you consider the old languages like Pascal, Basic, which came with C or?
Well, no, those were after C. I like, from a looking at programming today, I look at C as being an old language. I look at C as being the base. Everything that we look at today came from C. And at the very least, that's mostly a true statement. You have to go back pretty far to get stuff that didn't branch off C that we still use today. In fact, I can't name anything, to be honest. Every modern language that is still used today that I can think of is more than just related to C. I would say closely related to C. Flash is C. JavaScript is C. JavaScript, by the way, has nothing to do with Java. They just happen to both have the word Java in it. They're not related, not even second cousins. Okay, but they're both strongly related to C. Does that make sense? So for me, I tend to branch everything off of C. There was all sorts of languages before C. There was a language, me and a buddy of mine when I was maybe, when was this? I was young. I was probably 10 or 11. There was a language called Forth, the Forth programming language, and it was the language that the early Apple computers used to program their BIOS. So we used to write stuff in that and run it on his dad's, Apple I computer. So it was, nobody uses Forth anymore. Yeah, not Fortran. It was called Forth. Yeah, Fortran. Nobody uses Fortran really anymore either. Fortran's a good quiz question though. So if you ask the question about, what major element is missing from Fortran that's not missing from other modern languages? It's one thing Fortran's not capable of. That.
Is it the same with C?
No, C supports it. It's recursion. Yeah, Fortran does not support recursion. A function cannot call itself in Fortran. Breaks the language. So stuff like that. My wife she's a computer programmer as well. And she had a Fortran class when she was in college. And, nobody uses it. I mean, she uses COBOL now. She's a COBOL programmer. Nobody uses COBOL. Yeah.
Do they still use it?
COBOL? Oh, yeah. All these old, she works at Western Illinois University, and all their student record stuff and things are all written in COBOL because years and years and years and years ago, they made some bureaucratic decision that we're going to have programmers on campus who are going to write all of our stuff in-house. So they wrote custom stuff. So they have millions of lines of code written in COBOL.
Yeah, just to add 2 numbers, we have to write so many lines.
Yeah, so they have millions of lines of code. So they have a whole bunch of COBOL programmers for maintaining those and expanding those. Here on campus, we use a product called Banner. It does a lot of the same stuff. Okay, but it's written in a more modern language. In fact, I think Banner is written in Java. But regardless, they would have to make a decision. Do we take all that time that we've put into stuff, all these custom things, and move to something that's not going to move to something like Banner that solves the problem but doesn't reinvent all these thousands of custom functions we've made? Or do we just keep maintaining this? And companies like IBM are still making fortunes off this. See, IBM used to be cool, and they fly under the radar. See, Microsoft today is like the IBM back when Microsoft was getting started. Microsoft was the big dog, right? Okay, people have forgotten about IBM today. It's like, oh, are they still around? Okay, IBM, do they make laptops? Okay. IBM was the mainframe place, still is the mainframe place. Those are the computers Apple sells, it's mainframe computers that run COBOL. What else does IBM do? They create tools that allow really old technologies like COBOL to work with new technologies like web. So for instance, IBM has a tool called WebSphere. Cool sounding thing, right? WebSphere. So it's a machine and a piece of software. And it's very expensive. Oh, man, expensive. It's called WebSphere. You know what it lets you do? It lets you process web forms using COBOL instead of processing web forms using PHP
Was
or
Eclipse
Ruby.
originally by IBM?
Eclipse? Yeah. I think it still might be. It's an open source project, but IBM had something to do with it. And you got to look at that from these big companies as well. Half the time, these big companies are so big that one of their wings creates something that they don't even know about. When I taught at Western Illinois University, this was when a broadband internet was just kind of coming around. Locally, we didn't have a provider. So we had 2 local ISPs that made an agreement with the Verizon phone company to be able to sell DSL to us, early DSL. Well, then and there was an agreement they made, okay, in order to get the price to where they wanted it. So DSL was actually pretty expensive for us because the phone company didn't want to offer it in that town. Because they weren't, the town actually had a really small population when you subtracted the school's population from it. You have a pretty big state university, 25,000 students, 20,000 students, something like that. So during the school year, town was a pretty good sized town. During the summer, Town had 9 people. Okay. So the problem is that the school provided internet for all the students. So it wasn't worthwhile for Verizon to sell internet in town because most of their customers were seasonal customers and weren't even using their products because they were at the school. But in any case, so Verizon sold the DSL circuits to these local providers. All right. Well, then what happened is I don't know, must have been probably 8 months, a year later, something like that, when it became a little bit more mainstream. My wife and I got something in the mail that we could get 3 megabit per second download. Okay, we were getting 1.5 megabit per second download at the time for about $230 a month.
What year was that?
3
megabit per second. That was huge at that time.
2002, 2001, 2003, somewhere in there. So we were getting 1.5 megabit per second from the local providers, and we were paying an arm and a leg, right? Because they had made an arrangement with Verizon that said Verizon wasn't going to offer DSL in town, so the local providers could do it, and we were having to pay top dollar for these circuits. Okay, so it was expensive. All of a sudden, we get this letter in the mail that we can get 3 megabits per second for $30 a month or $50 a month, something like that. Something way, way, way cheaper. Twice the speed for like a sixth the cost. Well, sure, I played disc golf with the owner of Infobond Outfitters, the guy I bought my internet from in town, but man, if I could pay a sixth the cost for twice the speed, he's not my friend anymore. See ya, right? But what ended up happening, the punchline of this is Verizon ended up suing Verizon Online. The provider that was offering us that the cheap was Verizon Online, which was Verizon's nationwide internet service provider. So you have the corporate company Verizon, which is a POTS, a plain old telephone service company. That's the telephone company. Then you have this other business entity that is Verizon, okay, but it's called Verizon Online. It's a different business entity. And the way Verizon sells DSL circuits is the pricing of those circuits is based on how many ISP customers you have, how many internet customers you have. Okay, well, the two local ISPs in town had 5 customers. Okay, because they weren't getting the students. Yeah, maybe they had 1,500 customers, something like that. Well, how many customers do you think Verizon Online had across the entire country? A lot. Okay, so Verizon Online got those circuits for cheap compared to what the local guys could get it for. So Verizon, along with the local ISPs, turned around and sued Verizon Online. They sued one of their own companies. It was very, very entertaining. So in the end, Verizon Online, and what was funny is as a local, we didn't know who to root for. Well, I kind of want fast internet for cheap. I don't care if this guy could feed his kids. You see what I'm saying? It became a very interesting thing. So in the end, it worked out probably for the best. The local companies, Verizon Online was not allowed to offer in town. But Verizon sold circuits to the local companies as if they were the same size as Verizon Online. So they made an arrangement. So we got the 3 megabits for the same price as we would have paid Verizon Online. And the local providers were still getting their margin, because the circuit was a lot less expensive. The 1.5 megabit per second circuit probably used to cost them $200. Now it costs them $20 for a 3 megabit one, just because of that lawsuit. Just interesting stuff. So all these all these layers are all the same. All these big companies that just talk to each other, and yeah, I don't know. Okay, so I got to look at your homework again here and make sure you have everything you need. Then we need to talk about the test. Let's see. Create a class called card that represents a playing card. You can do that. Card has 2 fields, display value and suit. You could do that. Card should be able to display itself. You can do that. Create a class called deck that represents a deck of 52 cards. Okay, so that'll be an array of cards, array of card objects. The deck should be able to shuffle itself, display itself, and deal a card. Dealing a card should return the card from the top of the deck. Dealing a card twice in a row should not return the same card. That is to say that dealing the card changes the position of the top of the deck. Okay, so that's the programming assignment for this week. What I'll do is, I think you have everything you need to do that. I'm just going to show you a real quick thing here, just to kind of close up some of the gaps with the objects. We talked about a lot of good stuff today. I just need to show you one last thing. But what I'll do, like I said, next week I'm going to be in Florida. So I have somebody coming in to proctor the exam, and I'll go over some of the stuff I think will be important for the exam here in a few minutes. So we'll kind of walk through the stuff. But the exam's going to be comprehensive. It'll probably be 80% theory, 20% programming. So as long as you know all the theory stuff, you can do fairly well in the exam. If you want to ace the exam, you're going to have to be able to do the programming stuff. But if you just absolutely suck at programming live, then you skip you just leave those blank. You shoot for your 80% in the exam and move on with life. That's the punchline. I will not try to make the programming questions overly difficult, but for some of you that might still be too difficult. You know what I'm saying?
That will be writing out.
Writing out the program. Yep. So you will have 2 hours to take the exam. I will design it to take about an hour. Okay. So the goal of it is to not be a time pressure thing. So you should have plenty of time to do the exam. If I would leave the programming for the end, that's the stuff that's going to take you the most time. Some of you might be able to finish the exam in 20 minutes, especially if you're just going to blank the programming and walk. Okay. But in any case, it's closed book, closed note. So you have to do it all from your head. All from your head.
Programming, I can't try it.
No, can't try it.
Sure if it works or not.
No. I'll tell you if it works. Yeah, it's not my first rodeo. So when I look at your code, it's pretty clear whether somebody pretty much knows what they were doing or pretty much doesn't know what they were doing. I'm not going to take off points if you forget a semicolon or something. It's very much a competence thing. If I look at your code and it's like, oh, okay, this guy pretty much knows what he's doing. He made a little mistake here. This is like a little logic error, but he would have figured that out in the compiler.
Yeah.
Maybe I take off a point. Maybe I just leave it. Just depends on what it was, right? But typically it's polarizing. You get the person who you can tell knows what they're doing, just made a brain fart or something on the test, and then you get the people that should have just left it blank and they want partial credit because they wrote the word int. And the thing is, it's okay. It's okay. Especially, you guys are bridging that gap. We've talked about this because we're IT professionals in here. When you guys go out and into industry, you're going to fill different roles. Some of you are going to gravitate towards more of a programming role on the server side stuff. But some of you, where it's just not your cup of tea, you're going to become good at other things. Okay? That makes sense? Yeah, she never wants to program again. Okay? And that's okay.
Never, ever.
There's nothing wrong. There's nothing wrong with that. Okay? I wouldn't look so smart if she could program. So the punchline is it takes all types. Okay? It takes all types. In computer science, if we were on that side of the coin, it would be a bigger deal because computer science is substantially more programming in all parts of that field. But even having said that, you're going to have your strong programmers, you're going to have your weak programmers, and a lot of times your strong programmers are going to be doing more of the science-y, complex stuff behind the scenes, and then your weaker programmers, who aren't incompetent, they're going to do more of the grunt work front-end stuff. See, a lot of the front-end application stuff isn't hard, it's tedious. And I don't like tedious crap. So like when we go to these hackathons, we were talking about the hackathon, the programming competition stuff, I tend to work with the groups of the weaker students because, I have the patience to work with them. When you get some of our cocky computer science people who think they're programming gods, they don't have patience for somebody who can't write a hello world program. But, Yeah, I got one guy, he's already texted me. I told him I was flying down there. I can't ride in a car that long. And he's like, oh, you just want to make sure you're rested up so I don't beat you or something. I think I'll hold my own. I think I'll be okay. But I have fun going down there and teaching the students. It's a lot of fun and people learn stuff. But the punchline is, even at events like that, you're going to have your folks that really focus on the front end stuff that isn't complicated programming, but it's important programming. And then you have your people who are going to work on the back end stuff that is complicated programming. But you know what? You know what the judges care about? They care more about what it looks like. Okay? If it works pretty well and looks great to a judge, that's better than working really well and looking like crap. Every time. Yeah, so next time you have a really good programmer brag that they're better than you tell them that. Nobody cares how well it works as long as it looks good. Okay? As long as it works. It's got to work at some level, right? It can't just be really buggy. People don't have patience for completely broken, right? If a piece of software is broken, they don't have patience for it. But, if you have a video game that looks great and it works pretty well, it just seems a little glitchy, I'm good with that. As opposed to a game that just looks like crap, but it's just written flawlessly. All right, so you put those computer science guys in their place. We all have our talents, and so when you come into the exam, the purpose of the exam is to show me what you know. My job is to give you a grade at the end that indicates how well you've mastered the material, and the material is both theory and applied. And I make the exam mostly theory. Make sense? I throw the applied on there to separate the wheat from the chaff, but the point is, programming is not your thing. Get all the theory crap right, which is just going to be root memorization. I want you to understand it too. If you understand all these links that I've been talking about between the different languages and 3 different kinds of programming languages, procedural, object-oriented, functional, blah, blah, blah. If you understand all this stuff, that's good enough for what you need to come out of this class with. If you can also program some, that's a bonus. That makes sense? So that's where that 20% comes in. Worst case, you take your 80, you've done well in the homework assignments and stuff, get your B+ or A- or B in the class, whatever it is, and just go. Right? Move on with life. If you've done really well in the assignments and you come in and do reasonably on the exam, if you have A in all your assignments and you get a B on the exam, you'll probably get A in the class. It is what it is. Okay? I'm going to give you a grade that indicates how well you've mastered the material, and if you've shown me you can do the programming at on your own on the assignments, and you've shown me that you at least had a fighting chance on the exam. It's like, okay, well, if there was a gun to my head, I maybe could write hello world. Maybe. Okay. I'll figure out where to put you. You'll get a fair grade. All right? So let's see. So that's the assignment for this week. Let me just talk about the assignment for next week too, since I won't be here. So next week you'll come in. There'll be the 2-hour exam, and then the assignment, the final assignment, which you actually have 2 weeks to do. So take your time with it. What I would say is just email me when you submit it, and I'll go and grade it. But there's not a paper. There's a paper this week, but there's not a paper next week. Next week is just a programming assignment. It's kind of like a capstone programming assignment. And what I'll use that for is to buffer people who couldn't do the programming on the exam. I'll look more closely at that to try to pull their grade together. Okay? So for that one, let's see, where's the assignment part of that? Okay, so this week you're going to be kind of making some of the starting points for a card game. You're going to be making a card object and a deck of cards. Okay, so you'll be creating the stuff, the objects you might need to write a card game. Okay, so for next week, assign next week, due 2 weeks later, implement a modified version of the card game called War. You can go online and look at how to play War. There'll be plenty of examples on there. So in this game, there will be 2 players. Each player will be dealt 26 cards, so half the deck. So each player will have half the deck of cards. Okay? This week, you're going to be producing a deck that can deal cards. Next week, you'll actually be using that deck to deal cards. Okay? So each player is given 26 cards. the players do not get to choose which card they will play. Instead, the top card from each of the hands is played. So a total of 2 cards are played. So player 1 puts out a card, player 2 puts out a card. You don't have to have any sort of interaction with your players saying which card do they want to play. So if we're doing this in real life, I have 26 cards, you have 26 cards. I pull from the top of the deck and just lay the card out. That's my play. Let's see what you got. And you just do the same thing. Okay? Let's see. Instead, the top card from each of the hands is played, so a total of 2 cards are played. The card with the higher value wins, giving the player who played it a point. After 26 rounds, the game is over and a winner should be declared based on points. Make sense? In the event of a tie between cards, for example, 5 of clubs versus 5 of hearts, the tie will be broken as follows. Diamonds is the lowest value, followed by clubs, hearts, and spades is the highest value. So spades always beats hearts, always beats clubs, always beats diamonds in tiebreakers. So a 5 of spades is a better card than a 5 of hearts for scorekeeping wise. Make sense? All right, so that will be your final project. So really, what you're doing this week for next week and what you're doing next week for the final project are all one big project. But for this week to next week, you're just building the card object and the deck object to work with those things. Next week, you'll put those things to use. Okay? What I'll try to do is while I'm either while I'm gone or right when I get back, because it won't take me too long to do, I'll try to make a little video of the solution to that homework assignment after Wednesday. So make sure you get your assignment in by Wednesday. I'll look at the date, so I'll mark it late if it's not in by Wednesday for next week. But sometime shortly after Wednesday, maybe I'll just on Wednesday night or Thursday morning at my grandma's, I'll just write it real quick and I'll take a video of it and put up the solution. So you have a working solution of the assignment that's due next Wednesday. Okay, along with my speaking, me telling you why it works a certain way, so you'll see the solution. Okay, and then this last assignment should just be an extension of that. Okay, so for next week, though, you're going to show up and take a test. And then the assignment you're going to do for the following 2 weeks is already out there. So you can start working on it now if you want. Let's talk about this test then. Because actually the thing I was going to show you, you actually don't really need for any of these assignments. So we'll just leave it alone. So let's flip through the slides real quick, and I will try to point out things that I think are important. Okay? Because when I write this exam, I'm going to write it in terms of the things I want you to know. So I'll try to flag certain stuff that I think is important. Okay. Certainly, this idea of how human beings solve problems, memory, asking questions, and repetition. That's an important thing to me. And how programming languages mimic that. So that connection between how we solve problems, what the job of a programming language is, and how programming languages tend to solve those problems in terms of variables, conditionals, and loops. Okay, that connection is important. That will be on the test, guaranteed. The idea of the CPU, how the CPU is a collection of magic tricks. So that idea of low-level, high-level, and machine-level programming languages and how they have a relationship with the CPU. Low-level is a one-to-one. Every instruction in a low-level language is equal to exactly one magic trick the CPU knows how to do. Understand the nature of the CPU. So, important slide here, machine, low, high-level languages. Interpreted versus compiled languages, know the difference. You know, we talked a lot about that today. You know, when we go back over to this, all of these guys are interpreted languages. All of these guys are compiled languages. All of these guys are loosely typed languages. All of these guys are strongly typed languages. Okay? So all these things are related. Okay, so definitely interpreted versus compiled. I probably wouldn't ask a question about domain-specific versus general purpose. It's kind of, self-explanatory. Languages that solve very small problems are domain-specific. General-purpose languages are what we really consider to be programming languages. Okay, so I wouldn't worry about this. In terms of different types of programming languages, I won't ask anything dealing with functional, but I do expect you to understand the difference between procedural and object-oriented. That was that little phone example thing. Okay, that's important. Certainly loosely typed versus strongly typed. Understand the idea of creating a variable and what it means to have a type versus not having a type. Okay, I probably wouldn't get too in depth with this, but understand that languages come in two flavors from that perspective. History of the languages, I probably won't get too far into that. I might ask something at the surface, but I wouldn't ask you some weird, little tiny trivia question about, in what year did Steve Jobs get fired from Apple or something like that. It would be something that we repeated many times. Okay, could be something like the platform independence of Java. Kind of how does that work? That's an important thing with the Java virtual machine, where the virtual machine was ported to the multiple platforms, so you can write your Java program once and run it on Windows and the Mac and Linux, because the virtual machine was ported to Windows, the Mac and Linux. Let's see. That evolution stuff we talked about today isn't bad stuff. So I probably wouldn't ask you anything specific about structs, but there could be something in there about how we kind of moved from C to C++ to Java, kind of talking about maybe, in that argument, the difference between passing by value versus passing by address, that type of stuff. We use the example in class of, do you hand me the house or the address to the house, right? So understand those concepts. I wouldn't ask you to write any C code or anything like that. Let's see. So here's that virtual machine stuff, the platform independence of Java. And we looked at the same thing for the .NET, whether that's platform independent. I probably wouldn't ask any specific stuff, but that was the catch. C# is platform independent on any platform as long as it's Windows. That little joke. Why didn't Java die? I probably wouldn't ask anything from this. This is more just, how we got to where we are today in the world. Certainly, we start getting into now the theory of specifically the Java language. Syntax for defining a variable. You should definitely be able to define variables. You should be able to read code. There could be a question where I give you some code and ask you what this does. I wouldn't ask you to program it, but I might ask you to tell me what the output of this is. Okay? So know what variables are. Know what the different types are, specifically our primitive types. Knowing these things is going to be pretty good. Okay? Certainly, I probably wouldn't ask you to regurgitate these ranges and stuff, but asking a question like, why do we have so many different ways of holding unsigned or holding signed integers, bytes, shorts, ints, longs, the whole Y2K thing, because memory used to be expensive, all that stuff would certainly be fair game. I could ask you to list all the primitive types in Java, which would mean byte, short, int, long, char, float, double Boolean. All these guys are primitive types, not strings. Strings act a lot like primitive types, but they are not primitive types. Okay? Idea of bits versus bytes. I certainly could ask you a conversion problem. So you might have a little math problem on there. Convert, so many megabits to gigabits or gigabytes or something like that. Okay? Be able to go back and forth between these guys. We used an example of an internet connection. So I might give you a question like that. If you have a 50 megabit per second internet connection, what's the maximum download speed or something in megabytes or kilobytes or something like that? So you should be able to do the math. The concept of ASCII, I probably wouldn't ask you anything specific about that, but understand that ASCII to Unicode thing. That's a character mapping for chars. All right, so the char primitive type is actually an integer, but we like to use symbols. So it's a mapping between an int and the corresponding character in the Unicode character set. So understand where Unicode falls into the world. What's a Boolean expression? That should be, boom, any expression that boils down to a single value of true or false. Primitive arithmetic Boolean operators, I wouldn't ask you to spit these out, but you're certainly going to have to know how to use them, right? Same thing with the logical Boolean operators. I'm going to expect that you know how to use ands and ors. I wouldn't ask you probably a question specifically about them, but I would expect if I gave you some code that had some ands and ors in it, you could read it. And if you were writing a Boolean expression in one of your programs that you're writing in there, you should be able to use them. Nothing with the bitwise stuff, though. I wouldn't. XOR, bitwise, ands, or ors, we talked about those, but I won't ask you anything about those. Okay. Arithmetic operators, obviously. There certainly could be a question on there dealing with mod. I tend to like mod. like that guy. Syntax for asking questions are if statements. All of our loops, what each loop lends themselves to, kind of like those kind of questions. May or may not ask it, but it's fair game. So, your for loops, syntax for for loops, while loops, do while loops, understand variable scope. We talked about that a lot today, but we talked about that a lot as we were going through here. Okay. The plus plus and the minus minus operator, we talked about that again today. I tricked you, right? Okay, so understand that for quickly incrementing and decrementing stuff. Primitive type versus object types. This is where we started transitioning into that stuff. The idea of methods, reusable chunks of code. So be able to write methods, know the difference between class methods and instance methods. If I showed you the definition of a method, be able to tell me, is that a class method or instance method? If I showed you a method being used, be able to tell me whether that was a class method or instance method. Okay? Okay, so anything you hear me every single class do multiple times, that's probably going to be on there. Okay? And hopefully one day you're going to be like sitting at your desk and somebody's going to say something to you and you're going to like one of my little things are going to come back to you like, any expression was a single value, true or false. Okay. All of our string crap, manipulating strings, big deal. Okay, so working with strings, all these different string methods we learned about, length, char add, index of, some of the index of tricks that we looked at. They're not really tricks, but applications of that. Certainly arrays. We looked at the character class a little bit. I probably wouldn't ask you anything dealing with characters. I'll say it's fair game just in case I shoot myself in the foot, but I tend to gravitate more towards string and array manipulation stuff rather than seeing if you remember some quirky thing. Okay, so I care more about if we use something a lot like char at, index of, that's going to be pretty fair game. Is digit from the character class? I might, if I showed this to you and asked you if this was a class method or instance method, I would expect you to be able to answer that. But I wouldn't necessarily ask you to be able to come up with your need to use this method off the top of your head in one of the programs. It wasn't something that we used a whole lot. Okay? Almost done. I know we're a little bit over, but I want to make sure it's probably more important you know what's on the exam. So certainly class methods versus instance methods, same little stuff. We talked about this context a little bit more today, a static context versus a non-static context, when we need to use an instance to call it versus not needing an instance to call it. And the punchline is always use either the class name or the instance name. It'll never be wrong. Okay? I would never ask you a question that asks that I wouldn't provide you something and say, is this legal? When it technically was legal, but not a way that I would encourage you to write it. Like today we had some of those methods where I called it without using driver dot. I wouldn't give you code and say, is this legal? Expecting you to roll back on context. Okay? I would only show you code that I would think is appropriate code to write. Legal or, that's also legal. That makes sense? I won't try to trick you with poorly written legal code. Let's see. So more string methods. We looked at some substring stuff. Could make an appearance. We didn't use them as much, but being able to take parts or a portion of a string, important. Polymorphism, that's always a fun one. That might find its way on there. Certainly the string manipulation stuff. Number conversion stuff. It's entirely possible I would put what's 2,461 from base 10 to octal. Or base 10 to base 16, converting a number like that. That would be fair game. The concept of pointers, I might draw a picture and ask you something, or certainly defining a pointer, primitive type for holding a memory address. Pointers in terms of arrays, understanding you pass an array into a method and the method changes the array. That's a permanent change because it all pointed to the same place. So pass by value versus pass by address. The whole thing on arrays, how do you define them, what they mean, the idea of contiguous memory. Everything has to be in a row, so here's memory addresses in a row, here's the indexes and what that means. All right, so that's that. Let's see what was missing over here. I certainly haven't expected you to remember my phone number at the top of your... All right, let's see what we're missing here. So we had that. Certainly something from here, but I would not go over onto this side. So a lot of the stuff we talked about today was more big picture stuff to kind of see where things fit in the world. But for the exam, I'm going to be keeping you in this line right here. Kind of that C, C++, Java. You could throw Objective-C in there if you want, but I mean, it's all the same, right? Kind of our modern, high-level, general-purpose, strongly typed, compiled, object-oriented languages. So right in this line is really where you should be focusing. Okay, this stuff is more when you get out in the industry and they are looking for buzzwords. Now you kind of know where these things fit. Let's see. Same thing with this. This is important stuff, but not related to this class. You just got me off on a tangent. Yeah, this is a lot of the stuff we've already dealt with. Okay. So I think that's it. Like I said, I'll make the exam last about an hour. I'll design it to take, if you're prepared for it, I'll design it to take about an hour. But you will have 2 hours to take it. So at the end, it's actually another student who's giving it. So make sure you respect him enough to, at the end of 2 hours, give him your test and don't play hard to get. He doesn't have the experience I have of just grabbing it or just leaving. It's like, all right, so.
I have a question.
Yes.
Are there any extra credit opportunities for like 100 points each? Anywhere?
100 points each. No. But I'll say this. I mean, because you and I have made a separate arrangement. You don't have to come and take the test. Yeah, you will eventually. Yeah. But I mean, because of what we're doing, I want to do it when you have the best chance of success.
Yeah.
Okay, you get what I'm saying? So we'll work that out. Just don't worry about that.
Appreciate it.
Yeah, she's being treated fairly. We tried to put her in the online class, and it was a thing. It was a thing. So
You're gonna send us the slides.
the slides, I will email them right now. Any other questions?
Is it multiple choice or we have to write short answers?
All right, it's no multiple choice. It'll be all short answer essay type stuff. I'll have my email available the whole time I'm gone. So if you have questions or anything leading up to the exam, it'll probably be like methods and stuff like that. But like I said, about 20% of the exam will be programming.
There'll be partial credit for what we have.
Yeah, if you can show me some competence, I'll give you partial credit. So if you can't solve the problem completely, but you can show me that you kind of knew what you were doing, that would be very good. That gives me the opportunity to give you, 8 out of 10 points or 6 out of 10 points or something, But if you put like the word int in one curly brace, you give me nothing, right? So give me something to work off of so I can give you points. I'm your greatest fan, but you got to give me something to work with. Don't just leave it blank. All right, but I will have easy access to my email. I'm just going to be in Florida golfing and stuff, and be with my grandma. So if you do have questions early in the week, email me. If I don't answer within like a couple hours, email again to put it at the top of the inbox. But I'm not like on a cruise somewhere. I'll have complete access to my email and stuff. All right, I just won't be in this state. So feel free to ask questions. I want you to be successful in the exam. Anything else?
You have a good trip.
Yep, thanks.
Holiday for a person who needs the A and maybe doesn't do well.